And today I have handouts, 2 sheets for chapter 6, lecture notes, and plus quiz 5. Everybody here, you have come with these handouts. Please get ready, your notebook. This handout, the lecture notes, chapter 6, lecture notes. Scratch paper and table E. Table E. In chapter 6, we have a very important table E for us to study normal probability distribution. We use this distribution in all the remaining chapters. So it is a very useful, very frequently used probability distribution for us to study populations. Okay, everybody, repeat. Get ready. Your notebook. Chapter 6 lecture notes. Table E. Table E. Table E is at the back of your textbook. If you do not have textbook, you have to make a Xerox copy of this table. You have to use this table for us to study chapter 6 and the later chapters. Every later chapter you will need this table to work many probability and statistics questions. So you have to have this table. Today, if some of you do not have this table, you can share the table with a student next to you. Well, it is. Okay, quick, everybody, quick. Your notebook, chapter 6, lecture notes, scratch paper plus table E. Last time I told every student to get ready table E for the study of chapter 6. Okay, now let's begin. Look at your chapter 6, lecture notes 6.1. In chapter 5, okay, don't talk. Don't talk. In chapter 5, we started to learn random variables. When you study random variables, look at both. You do not need copy. We say that already. You have them in your notes. When you study random variable, there are two related issues. One is how many possible values are there for the random variable to take one. The random variable takes one value out of those many possible values. So you have to know what are the possible values for the random variable to take. Like when you study binomial random variable, it tells you how many numbers, how many successes do you get within n trials. So the possible values are 0, 1, 2, 3, up to n. And the random variable takes one out of those possible values. This is the first issue. Every random variable has many possible values. The random variable takes one out of those possible values. By chance. The second issue is the chance. Probability distribution. Probability distribution. It tells you how likely the random variable takes this value or it takes that value. This is called the probability distribution. In chapter 6, we learned this kind of random variable called a continuous random variable. Now let's understand the discrete continuous. In chapter 5, those random variables are discrete. What does it mean? It means those possible values, they have gaps. For example, in chapter 5, maybe you set a random variable. It represents how many correct answers a student will get if he make a random guess when he work a test, multiple choice test. How many possible values? The possible values may be 0, maybe 1, maybe 2, maybe 3, maybe 4, but it cannot be 2.3, 2.4, 2.5, impossible. So 2 is a possible value, 3 is a possible value, but any number between 2 and 3 are not possible values. Another example, binomial random variable. You want to find how many successes you will get within n trials. 0 is a possible value, 0 successes, that means orphan. 1 is a possible value, 1 success. 2 is a possible value, 2 successes. 3, 4, 5 are all possible values. But any number between 1 and 2, between 2 and 3 are not possible values. You cannot get 1.2 successes. You get 5.5 successes. Impossible. So those possible values, they have gaps. They have gaps. Between two possible values, some numbers are not possible values. Such kind of random variable values are called discrete. On the other hand, continuous, what does it mean? For example, suppose you check temperature. Temperature, say 72 degrees, a possible value. 73 degrees, a possible value. But any number between 72 degrees and 73 degrees is also a possible temperature. No gap, continuous. Suppose you measure body height, say 65 inches, okay, a possible body height. 66 inches, a possible body height. Any number between 65 66 is also a possible body height. No gap, no gap. It is called continuous random variable. In chapter 6, we study continuous random variables. Now, look at your handout, today's quiz. The first problem. Okay, great. Look at today's handout, quiz 5, problem 1. Please remember, please remember, do not write anything on quiz. We just discuss quiz problems to learn something, and you work them at home. Quizzes are for you to work exercises at home, not in class. So do not write anything on the quiz.
So something like weight, height, temperature.
Continuous. Continuous. Now everybody look at your quiz, today's quiz, problem number 1. There you see several examples. I want you to decide whether this kind of random variable values are discrete or continuous. Let's have a look. Everybody now please look at quiz 5, problem number 1. There, it's yours. No problem. There you have several examples. Some are discrete, some are continuous. Today's handout. No. Today's handout. This is today.
No pieces.
So nothing else.
Ghana tell quiz.
Everybody concentrate.
On the quiz.
I ask you to look at quiz 5, problem number 1, but don't write, just look. There are some examples. The question is, do you think this is a continuous random variable, a discrete random variable? Look at the first example. You use x, random variable x, to represent the body weight. You randomly select a person, measure his or her body weight. That is a possible value. Do you think this kind of values are discrete or continuous? A, continuous. Because any two possible body height between any two possible body weights, any number is also a possible body weight, right? For example, 150 pounds is a possible body weight. 149 pounds is a possible body weight. Between 149 and 150, any number is a possible body weight, right? No gap, right? No gap. So this is a continuous random variable. Those possible values, we call them continuous time. Now look at the B. X represents the number of credit cards a person has. Possible values, 0, 1, 2, 3, 4, right? Suppose possible value 0 and possible value 1. Do you understand any number between 0 and 1 is not a possible value? A person cannot have 0.2 credit cards. No, impossible. A person will not have 1.1 credit cards. No, impossible. The possible values could be 0, 1, 2, 3, 4. Any number between 0 and 1, any number between 1 and 2 is not a possible value, correct? So this is for the what type? Discrete type. Let's go on. Please understand there are two kinds of possible values. Discrete, continuous. Let's understand the discrete, continuous. How about 1C? Pulse rate. Pulse rate, how many beats a minute? Say maybe 70, maybe 71, maybe 72, right? Is this discrete? Is this continuous? Discrete. Because 70 is a possible value, 71 is a possible value, but not the 70.3, 70.4, 70.5, 0.66. No. So this is discrete time. Go to D. It represents the lifetime of LED light bulb. Lifetime, say 1,000 hours, 1,001 hours. Possible value. How about any number between 1,000 and 1,001? 1,000.5, 1,000.6,
Yes.
0.555.
That's right.
It's okay, right? Any number between two possible lifetime is also a possible lifetime, right? Do you understand that?
Yes.
So it is of what kind?
Continuous.
Yes. How about E? E represents the height of a building. Maybe say 100 feet, or maybe 200 feet. Continuous, right? Because every height is a possible, every measurement is a possible height. So this is continuous. Look at F. F represents the number of cars sold a month. Discrete, right? Discrete. Okay, go to G.
Answer it all immediately. You
The
answer it.
distance. Distance, the measurement is how many miles or how many feet. Continuous, right?
Yes.
Now, in chapter 5, we handle discrete random variables. Now in chapter 6, we handle continuous. Now everybody go back to your lecture notes. 6.1. Put your quiz aside. Remember to carefully work quiz at home. You have to clearly understand how to work quiz problems by yourself. You can discuss, but do not copy. Copy, you still don't understand. when you clearly understand how do you work with problems, you should be able to successfully work test problems. In the next test, you will be allowed to refer to your own quizzes. Okay, put your quizzes aside. Now, go to your lecture notes 6.1. Please read the first part. 6.1. Read item 1. Take 1 or 2 minutes. Carefully read item 1 to understand continuous random variable. Okay, please carefully read item 1 under continuous random variable. Take 2 minutes. Everybody take 1 or 2 minutes. Please read item 1. Continuous random variable. We explained just now. Have you finished reading item 1? Now, please understand in chapter 6, we work continuous random variables. Now, the second issue of random variable is probability distribution. Now, let's have a review. Chapter 5. In chapter 5, how do we express probability distribution? Look at model but do not copy. Look at model but do not copy. In chapter 5, we use a table to describe the probability distribution. Here, you list all the possible values. Say, all the possible values. Here, you put the probability for the random variable to take this one as an actual value, take this one as actual value. 10% chance the random variable takes 0. 5% chance it takes 1. Do you remember that?
Yes.
Or we use a formula. You say the probability equal x takes 1 equals how many? The probability x equals 2. How many? Use a formula to calculate. Do you remember that?
Yes.
But when the possible values are continuous, can we use this method to show that? No. Why? Because you have infinitely many values. So it's possible for you to use this way to study probability distribution. Do you understand that?
Yes.
So we have to use a new method to study the probability distribution. The new method is called that. Look at your lecture notes. The new method is called density function. Item 2. The probability distribution of a continuous random variable is given by a density function. Now please understand how do we work it. Look at look at the 2 first. In math 1 to 5, you studied some basic knowledge of functions. A function you can graph it. Look, Suppose the domain of the function is from here to here. The function works for these x values. And you can graph it. You can graph it. You can graph it. Do not copy, just listen. Did you study the functions in math 125? Do you remember you said that in the exam? You, of course, you learned some basic knowledge, but that's enough. A function you can graph it. A function you can graph it. Suppose this graph represents some function, and it works for the x values from here to here. From here to here. And this is called the domain of the function. Now, for density function, it is a special kind of function. What's special kind? First, this function must be above x-axis, cannot be below. Secondly, if you graph the function, the area under the graph represents the total probability. So the area must be what? 100% area. Now, sorry. Now let's understand how do we make use of the density function to work probability questions. Let's finish reading the lecture notes set. Then we look at the examples. Okay, everybody look at your 6.1 lecture notes. Item 3. Don't worry much about that. I do not expect you will understand it right now. You will understand it after you work exercises. But first, let's read. Item 3. It says the density function. The graph of density function is called a density curve. For example, this curve is density curve because it represents the density function. Now comes the most important thing about the density curve of any continuous random variable. The important factor is the total area under any density curve is always 1 because it represents what? It represents the total probability. It is true for whatever continuous random variable. Any continuous random variable, the curve will look quite different. The curve will look quite different. But the one thing is in common. The total area under the curve must be 1. Because the total area represents the total probability. Total probability is always 1, whatever random variable. Go to 4. In chapter 5, the question will be, what is the probability for the random variable to take value 3? What is the probability for the random variable takes value, say, 12? The question will work like that, equals something. Sometimes you see greater than, less than. Sometimes in chapter 5, the question like that. Do you remember how do you work that? You said this equals x equals 1 plus x equals 2, 1 plus x equals 2, right? Do you remember if the question is like that? answer it, you find these, then put together to answer the question, right?
Yeah.
So in chapter 5, the question is equal. But in chapter 6, the question is no longer equal. In chapter 6, what is the question? In chapter 6, the probability question will be this. Listen carefully. What is the probability for the random variable to take a value between a number and a number, between 3 and 5, between 1.5 and 2.6, between. Equal sign there or equal sign not there will not make a difference. In chapter 6, sometimes you see what is the chance for the random variable takes the value less than 5. Less than 5. This side is missing. Then you understand this side is the smallest possible value. Smallest possible value. If this side is missing, that means the smallest possible value. On the other hand, if you see problem like that, say x is greater than 5, the other side is missing. Then the other side, people understand the largest possible value. So in chapter 6, the question is always like that. In chapter 6, the question is always like that. If this side is missing, you understand as the smallest possible value. If the other side is missing, you understand it as the largest possible value. So the basic question in chapter 6 is like that. Now, how do you answer the question? You make use of the density curve. Suppose C is here, say 3. D is here, say 8. Now, if you want to, suppose this is 3. Suppose this is 8. Now, if you want to answer the question, what is the chance for the random variable takes the value between 3 and 8? How do you answer it? The answer is, listen carefully. The answer is the area between 3. The answer is the area between 3 and 8. This is a basic idea in chapter 6. Okay, repeat. In chapter 6, the question is like that. The answer is the area between C and D. If C is not there, they assume the smallest value is the area. If the D is not there, if there's this side is missing, then you assume the largest possible value, this area. Anyway, the answer is the area. Now the next question is how do you find area? Do you understand? The next question is how do you find area? How do you find area? Generally speaking, in calculus, you use integral to find area, but we do not use integral. First, here nobody studied integral before. Second, when the function is not simple, the integral itself is very complicated. Even if you studied the integral before, it's still very difficult to use the integral to find the area. So how do we find the area to answer the question? We use a table to help us to work it out. This is why you need a table. Last time I told you every student, if you do not have a book, you must make a Xerox copy of this table to work at chapter 6 and the later chapters. In chapter 7, chapter 8, chapter 9, you still need the table. So everybody, you have to have the table. Some students use Therefore, to take a picture of it, it's not good because for the picture, you only can see a part of the table. If you want to see the entire table, then it is too small. I do not think you can see the entire table once in the cerebral screen. So you still have to make a Xerox copy of this table to study chapter 6, 7, and the later chapters. Later in chapter 7, you need table F, table G, up to table H. But in chapter 6, you need this table. Okay, now please read continuous random variable. Item 1, item 2. You have finished reading. Now please read item 3, item 4. To understand the general idea. Please read item 3, item 4. Take 2-3 minutes. Carefully read line by line. Remember, you have to read them again after class to review. Now everybody, let's go up. Please get ready your notebook plus table E. Go to item 2. Let's understand a very useful probability distribution called the normal distribution or bell-shaped distribution. Because in real life, many populations roughly follow bell-shaped distribution. So this probability is a very, very useful model for us to study populations, which is called a normal distribution. Now, first let's understand some basic knowledge of normal distribution. A normal probability distribution is symmetric. If you graph the density function, you see the graph looks like bell, It looks like a bell, like this. So we call it a bell-shaped distribution. A normal distribution is a bell-shaped distribution. The bell-shaped distribution, the curve is determined by two numbers. One number is mu, mean value. One number is sigma, standard deviation. Remember, every random variable has mu, has standard deviation. In chapter 5, how do we calculate the mu? Let's have a review. You take sum every possible value times its own probability, right? Do you remember that? in chapter 5.
Yep.
And in chapter 5, how do you find standard deviation? You take square root of variance. How do you find variance? You add all the possible values square times its probability, then minus the mean square. You calculate this, take square root, you get mu and sigma. This is chapter 5 for discrete random variables. In chapter 6, those random variables are continuous. But they still have mu, they still have sigma. Now, when you study normal distribution, the mu and the sigma you do not need to calculate because they must be given. When you study a normal distribution, the mu should be given, the sigma should be given. Then you can study the population. You can study the normal distribution. So, repeat. Look at the first item. A normal probability distribution is bell-shaped, symmetric. The curve, the function is determined by two numbers. One is mu, one is sigma. They are given. Now go to 2. If x is normal random variable with the mu given, with the sigma given, then it is a continuous random variable. The density, the notation. This is an abbreviation of the normal. Because the distribution is determined by two numbers. First number mu, second number sigma. Remember, sigma must be positive. The mu can be whatever. Positive okay, negative okay, depends on the nature of random variable. But this one must be positive. Remember that. This one must be positive. Standard deviation must be positive. This one can be whatever. Okay, in chapter 6, we learn this. And normal, that is bell-shaped, symmetric distribution, determined by these two numbers. They are even. Now let's go on to understand how do we study such kind of normal random variable. How do we make use of them to study real-life populations? Number 3. Don't worry about number 3. We said any continuous random variable has a density function. Now look at the density function of normal probability distribution. It looks complicated. Don't worry about that because we never use this one to calculate. We use the graph. We use the graph of this function. The graph is this. We use the graph. And we use the graph to study the area under the graph. We use the table to work